Today we study section 4.1. There were two topics. Topic 1 is maximum and minimum function values. Topic 2, how to locate maximum and minimum function values. Here we have the graph of some function f of x. Let's consider one portion of this graph. The portion over the interval from BA to BB. That is the portion from this point here to this point. About this portion of the graph, clearly this point is the highest point. So function value at this point, function value is the y-coordinate of the point. So function value at the point f of d is the maximum function value of the function on this interval BA to BB. Yeah, it is important to emphasize that maximum function value on this interval. That means that maximum function value of this portion, not the maximum function value of the whole graph. The whole graph, if you consider the whole graph, clearly this point is not the highest point. This is the highest point only of this portion. In the book, maximum function value is also called maximum value or absolute maximum value or global maximum value. So when you read the book, when you read one problem in the book, if the problem asks you to find maximum value, that means that find the global maximum value. This point is the highest point of the portion that we are considering. This point clearly is the lowest point of the portion that we are considering. So the function value at this point, the y-coordinate function value, the function value f of BA is the minimum function value over the interval from A to B. From A to B. Yeah. This is important to emphasize that minimum function value on this interval. That is minimum function value of this portion, not the minimum function value of the whole graph. Similarly, in this book, the minimum function value is also called minimum value, absolute minimum value, or the global minimum value. Then what are extreme values? Maximum value and minimum value, they are also called extreme values. Yeah, we have considered the highest point and the lowest point. How about other points? Say, how about this point? Clearly, this point, globally, it is not the highest point. But locally, it is the highest. So we say that the function value about this point, the y-coordinate, the function value f of B is a local maximum function value. Over this interval, BA to BB, from BA to BB, this portion has several local minimum function values, local maximum function values. Yeah, this is locally maximum. This is locally maximum. Of course, this point globally, it is also maximum. And this point locally, it is maximum. So over this interval, the function has three local maximum function values: f of b, f of d, and f of bb. Because bb is an endpoint, so the book doesn't count f of bb as a local maximum because bb is an endpoint of the interval. This is a convention. Yeah, this book, okay, doesn't count local maximum, local minimum at endpoints. Similarly, the function f has three local minimum function values: f of ba, locally minimum; f of c, locally minimum; f of e, locally minimum. So the function has three local minimum function values on this interval ba to bb. Again, the book doesn't count f of a as a local minimum because a is the left endpoint of the interval. This is a convention. You can find this convention in the book on page 244. This convention says that local maximum values and local minimum values occur only at interior points of the interval of interest. Interior points. A point that is not an endpoint is called an interior point. However, global maximum and global minimum can occur at interior points and also at endpoints. Have a look at two examples. Example 1, consider the function cosine. This is the graph of cosine. We know that cosine is between -1 and 1. So the graph of cosine lies between these two horizontal lines. The top horizontal line corresponds to 1, and the bottom horizontal line corresponds to -1. Consider the function cosine on this interval, -infinity to +infinity. In other words, we need to consider the whole graph of cosine. About the whole graph, the maximum function value of cosine is 1. This maximum function value, 1, appears infinitely many times because cosine of 0 is 1, cosine of 2 pi is 1, cosine of 4 pi is 1, cosine of -2 pi is 1. So this maximum function value, 1, appears infinitely many times. 1 is a global maximum function value. Yes. It is also a local maximum function value. Also a local maximum function value. A local maximum function value may not be a global maximum function value, but a global maximum function value must be a local maximum function value. How about minimum? The minimum function value of cosine is -1. Again, -1 occurs infinitely many times because cosine of pi, -1, cosine of -pi, -1, cosine of 3 pi -1. So -1 occurs many, many times. Example 2. Consider the function x squared. This is the graph of x squared. It is a parabola. Consider the function over several intervals. A, over the interval from -infinity to +infinity. That means that we need to consider the whole parabola. Questions. What are the maximum function value, minimum function value, local maximum, and local minimum over this interval? Because the parabola, the whole parabola, has no highest point. So maximum, here maximum means global maximum. Low global maximum, none. This point is the lowest point globally. So the function value at this point, 0, is global minimum function value. The location is x is 0. Local maximum, low point on the parabola, locally, it is maximum. So the answer is none. Local minimum, this point, globally, it is minimum. Locally, it is also minimum. So local minimum function value is 0. 0 function value. This 0 is the location of the function value. X is 0. Part B. Consider the function over this interval 0 to 1. This is a closed interval. Over the interval 0 to 1, that means that we consider this portion of the parabola. The interval is a closed interval, so we put a solid point here and solid point here at the two endpoints, including the two endpoints. About this portion, this point is the highest point, so the function value at the point is 1. Then is maximum function value. The location is x is 1. This point is the lowest point of this portion. So the function value at this point, 0, is a minimum function value. The location is 0. About local maximum. This point, locally, maximum. But this point is an end point. The book doesn't consider an end point as local maximum by convention. So the answer is low local maximum over the interval 0 to 1. And similarly, low local minimum over the interval 0 to 1. Part C, go back to the problem. Part C is consider the parabola over this interval. Now, excluding 0, but including 1. Yeah, this portion, we consider this portion of the parabola. Excluding 0, so put an open dot there, including 1, a solid point here. Same questions. The maximum function value, the global maximum function value, okay? This point is the highest point of this portion, so the function value at this point is maximum function value. This one is location, x is 1. How about global minimum? About this portion, this point, globally, it is the lowest point, but this point is not part of this portion because open dot there. So no minimum function value. local maximum. This point locally maximum, but this point is an M point. The book doesn't consider it as local maximum by convention, so the answer is none. Local minimum, this point locally minimum, but this point is not part of the portion that we are considering. So the portion that we are considering has low local minimum. So the answer is none. Part D. Part D. Consider the function over this interval, now this time, including 0 but excluding 1. Including 0, so solid point here, excluding 1, open point here. So we are considering this portion. Maximum. This point, maximum point, but this point is not part of the portion that we are considering. So the answer is none. Minimum. This point, solid point. Low, globally, it is the lowest point. But this point is the end point, the left end point of this portion that we are considering. End point, we don't count end point as local minimum. So the answer is local minimum. The answer is none. No local minimum over the interval 0 to 1. This interval is including 0 but excluding 1 on this interval. Low local minimum. E. Part E. Part E. Consider the function over this open interval. Now this time, excluding 0, excluding 1. Yeah, this is the corresponding portion, excluding open dot at left end point, open dot at the right hand point. So the answer is maximum function value, low maximum function value, because this point is not part of the portion that we are considering. Minimum, yeah, this point is minimum, but not part of the portion that we are considering. So the answer is a low minimum function value. Local maximum, this point, low local maximum. And also low local minimum. Yeah, both these two points are not part of the graph that we are considering. This is example number 2. Next page. From example number 2, we saw that whether or not a function has a global maximum value and a global minimum value actually depends on the interval that we are considering. The same problem, but we consider the interval 0 to 1, excluding 0, excluding 1, then low maximum, low global maximum, no global minimum. If we consider the portion corresponding to the interval 0 to 1, but including 0, including 1, then the function has maximum, global maximum, and global minimum. So whether or not a function has maximum and minimum actually depends on the interval that we are considering. There is a theorem in the book. This theorem guarantees, under some conditions, the function must have maximum and minimum. This is a guarantee. You can find this theorem in the book on this page. This theorem is called extreme value theorem. Extreme value, maximum, minimum value, they are called extreme values. This theorem says that if the function f is continuous on a closed interval AB, then the function f must have a global maximum and a global minimum on this interval. You can test this theorem by arbitrarily draw a curve, a continuous curve. Let me draw a continuous curve, arbitrarily draw. The interval AB is a closed interval. At the point A, the function has function value. Say this solid point, function value here. At point B, the function has function value, solid point here. The function continuous. Then this theorem says that the function must have a maximum value and a minimum value over this interval. Yeah, this point, the highest point. So the function value at this point, the y coordinate, is maximum function value. This point is the lowest point. So the function value at the point, the y coordinate, is the minimum function value, guarantee. However, if a function is not continuous, then no guarantee. The function has a global maximum or a global minimum. Here is one example. The interval AB is a closed interval. At A, function value is this solid point. At B, function value is this solid point. Now let me draw a curve. Now this time I let the curve have a jump here, a jump. Then over this interval AB, the function has no maximum. This point is the highest point. But this point is not part of the function. At this point, no function value. So therefore, this function has no maximum, no global maximum function value over this interval AB. This is one example when a function is not continuous. No guarantee. So only when the function is continuous and the interval is a closed interval, function is guaranteed to have a maximum and a minimum on this interval. If the interval is an open interval, also no guarantee. One example is here. Go back to example 2. Yeah, this case. The interval 0 to 1 is an open interval. So low maximum, low minimum. Second topic, locate the extreme function values. Again, one extreme function value means a global maximum function value or a global minimum function value. The extreme value theorem in topic 1 guarantees the existence of extreme values, but the theorem doesn't tell us where the extreme values are. Okay, now in this topic, I will tell you 3 steps to find extreme values. To locate extreme values, we need the following observation. Suppose the function is continuous on a closed interval AB. By extreme value theorem, it is guaranteed that function has a maximum and a minimum on this interval. Then the maximum and minimum values of this function can only appear at the following points. They cannot appear at other points. Maximum and minimum can appear at endpoints. Say, this is one example, say, appear at endpoints, left, right endpoint. Maximum and minimum, number 2, can appear at interior points where derivative is 0. Derivative is slope of tangent line. So that means that where tangent line is horizontal. Interior point is a point that is inside the interval between A and B. An example, say here, look at this curve. Maximum is here, so there, tangent line, horizontal, derivative there is 0. This is a minimum point. There, tangent line is horizontal, or derivative is 0. Number 3, maximum and minimum can appear at interior points where derivative doesn't exist. Derivative doesn't exist, that means that the curve has a corner there. This is one example. The curve has the minimum here. This is a minimum, the lowest point here. So at the point, the curve has a corner. Derivative doesn't exist. So maximum and minimum function values can only appear at the points of these 3 times. Either possible to appear at endpoints, possible to appear at a point where tangent line is horizontal, also possible to appear at a point where the graph has a corner. In this book, a point C where derivative is 0 or derivative doesn't exist. The point C is called a critical point. A critical point. So with the definition of critical point, this observation can be simplified, can be rephrased as the following observation. Suppose a function is continuous on a closed interval. So by extreme value theorem, the function must have a maximum and a minimum over this interval. Then the maximum and the minimum values of the function can only appear at the following points. Endpoints, possible. Interior critical points, yeah. This is a critical point. This is a critical point. Interior critical points. Based on this observation, then we have the following 3 steps to locate maximum and minimum function values. You can find these 3 steps in the book on this page. And these 3 steps, we give a name to these 3 steps. We call these 3 steps the closed interval method to find extreme function values. Okay, now take a look at the 3 steps to find the global maximum and minimum function values of a continuous function on a closed interval. 3 steps. Step 1, find all the interior critical points. C1, C2, Cm. Suppose there were m critical points. All these m critical points inside the interval. Yeah. Say, look at this graph. Okay. Step 1 means find this point, C, corner. If this graph, then critical point is this point, right? Tangent line horizontal, and this point, tangent line horizontal. So find these 2 points. Find all the critical points between A and B, open interval between A and B. Then second, compute function values at the critical points. Yeah, here, compute function values at this point. Compute function values at this point and at this point. And also compute function values at the 2 endpoints. Compute function value at A. Compute function value at B. Compute function value at A. Compute function value at B. Now compare these function values. Say focus on this graph. So we have 2 C1, C2. Compute function value at C1. Compute function value at C2. And also compute function value at A, compute function value at B. Now we have 4 function values. Compare these 4 function values. The largest function value in step 2 is the global maximum function value of the function over the interval. Yeah, so function value, function value, function value, function value. The largest is here. So this is the global maximum over this interval. And the smallest function value at step 2. Yeah, here. 1, 2, 3, 4. 4 function values. The smallest function value is here. Yeah, is the global minimum, absolute minimum function value of the function over this interval. So yeah, this point, this function value is the minimum function value over this interval. About the closed interval method, in the next class, I will show you examples about how to use these 3 steps to solve problems. Okay, examples in the next class for these 3 steps.